All right, here we go. So this video, it is section 4.3. We're going to continue on. This is what I meant to have ready for you yesterday, but I forgot to do it, so I'm doing this now. So you guys should have this for today, which is Thursday. So here we go. It says 4.3 is trigonometry extended. So back, excuse me, back in the last couple sections we've been reviewing. Okay, we've been reviewing a trig. We've also been reviewing special right triangles, that kind of thing. So this we're going to take it a little bit further. All right, we're going to actually try to apply this right triangle stuff to the circular functions. Okay, so here we go. So first of all, guys, we need to understand what positive, negative angles and what standard position is, because if we want to put an angle, if we want to place an angle on a coordinate plane, you need to place it in standard position. So first of all, what standard position is, you always put the vertex on the origin. So my vertex right here is on the point 0, 0. Okay, and the initial side is always on the positive x-axis. So this right here is going to be your initial side. And this right here is going to be your terminal side. Okay, so always, what I would think about, guys, always think about starting your angle. Your angle would start at 0 degrees. Now, if you want to put like a 120 degree angle on the coordinate plane, then you would have to open your terminal side up this direction counterclockwise, because positive angles are generated by counterclockwise rotations. Okay, so if you open your terminal side up to 120 degrees, that right there would look like a 120 degree angle. Okay, I guess I could write 120 in there if I wanted to, but that would be a 120 degree angle. If I open it 120 degrees, remember, counterclockwise is positive. If you open the angle clockwise, that's going to be a negative. Okay, a negative angle would be opening up clockwise. So if I went this direction and got to the same point, I think that would be like negative 240. So if I got to the same position, to the same standard position, just going this direction, that's going to be a negative and 240 degree angle as well. Okay. So this is the idea. Like I said, always in standard position, you always put your vertex on the origin. So at the point 0, 0, that's your vertex. One of your sides is always going to be on the positive x-axis. If you open it up counterclockwise, it's positive. If you open it up clockwise, it's negative. All right. So this kind of leads me into the next, what I would usually call slide, but I'm going to flip over this whiteboard here. We're going to talk about coterminal angles next. So hopefully everybody has that written down. If you don't, pause the video. But we're going to talk about coterminal angles next. I kind of already given you an example of a coterminal angle, or of two coterminal angles. So if I open this up 120 degrees this way, that's the same thing as opening up 240 degrees the other direction, so negative 240. So guys, what 120 and 120 and negative 240, those are actually called coterminal angles, and I'll try to explain that in this next quote-unquote slide here. So here we go. Coterminal angles. They are angles that have the same initial and terminal sides but different measures. And we've given an example already, 120 and negative 240. Those are coterminal angles. But I'm going to explain this a little bit further. Okay, so write this down. I'm going to go ahead and talk about it here. So pause the video if you still need time to write it down. But here we go. So to talk about this, I'll go and stand in front. You can't see my face, but that's okay. So if I was talking about a coterminal angle, so for example, let's say my position facing the camera, let's say that's 0 degrees right now. Okay, it is. Let's just say it's 0. If I wanted to get back to the same position, but let's say I go this direction and I get back to the same position, how many degrees did I just go? You guys should be able to answer that. That would be a 360. So if you ever watched any Olympic sports like snowboarding, I think skateboarding is becoming an Olympic sport, anything that deals with spinning or turning, something like that, They'll say 360, 720, that kind of thing. So guys, if I kept going, if I go around the circle one more time, I'm back to the same position. But now I've gone 720 degrees because I've gone 360 degrees more, okay? So hopefully that makes sense. If I went around again, I'd be to 1080. Okay, so those are all coterminal angles because I'm in the exact same position, right? Right now I'm at 0 degrees, or if I turn around once, I'm at 360. If I turn around twice, I'm at 720. I'm at the same position, but I've rotated a couple of times, all right? So that's what coterminal angles are. They're angles that have the same initial and terminal sides, but different measures. So the example I had here is 0, 360, 720, 1080. I'll just say ... Those are all coterminal angles, okay? I also could have done negative. So if I called this a positive 360, I could have went around the other direction and said that's a negative 360. Okay, so that's the idea. So we're just going to do a couple examples with coterminal angles. They're really simple to find coterminal angles. And let's go ahead and get to that. So I'll just use the same slide here. All right, so I have some directions to write down here. So let me go and do that. It might take me a little bit. Oops. Example, find a positive and negative coterminal angle. Okay. With the given angle, but I won't write that down. So part A is going to be 30 degrees. All right, and I'll try to fill in part B and C later. There's 3 parts to this. Okay, so this is very simple, guys. Again, to find a coterminal angle, we just want to find an angle that's essentially in the same position as 30 degrees, but it has a different measure. So instead of 30, we'll have a different number instead. So for example, let's just try to plot 30 degrees. Let's try to. You don't have to draw this every time, but let's just go and draw it here just for the fun of it. So first of all, whenever you draw an angle in standard position, your initial side's always on the positive x-axis. Your vertex is always in the middle here. And I want to go 30 degrees. So I want you guys to kind of test yourself. Does that mean I go counterclockwise 30 degrees, or do I go clockwise 30 degrees? Well, since it's positive 30, that means we need to go counterclockwise. So if I open this up counterclockwise, it's this direction. Okay, hopefully you guys are seeing that. So this right here would be 30-degree angle, and that's my angle. I've got it plotted on the coordinate plane in standard position. Okay, so that's the idea. I want 2 more angles. I want a positive coterminal angle to that, and I also want a negative coterminal angle to that. So meaning I want an angle that's going to be in the same position as 30, okay? The terminal side is going to be in the same spot as 30 degrees, but it's not going to measure 30 degrees. It's going to be more or less. So in this case, let's go ahead and start with positive. If I start, so for example, let's say now I'm at 30 degrees, okay? So I kind of turn my body. I'm not at 0 degrees anymore. How could I get back to the same position, but just it'll be a different measure? The answer is I could go all the way around one time. I could go 360 degrees from here. So now I'm back to 30 degrees in relationship to the camera. Hopefully that makes sense. I'm back to the same position. I'm not back to 30 degrees. I'm back to the same position. How many more degrees did I go? Well, 360. So guys, this is as easy as it gets. All you need to do is take 30 plus 360. And that's 390. So a 390-degree angle would be the same thing. It's in the same position as a 30-degree angle. Okay, so hoping that's clear. Now again, I'm at 30 degrees. Okay, now let's say I wanted to make a negative coterminal angle. So instead of going that direction, I could go this direction. And couldn't I do the same thing though? Go all the way around, so go 360 degrees from here. and I'm back to 30 degrees. Hopefully that makes sense. So instead of adding 360, what can I do to get my negative coterminal angle? Well, I kind of gave it away. You could subtract 360. So that's negative 330. So here's the idea. So going 30 degrees this direction, we're going to wind up in the same position as if we go 390. So if I go 30 and then 360 more, I've done a circle, right? So if I've gone 30 plus 360, that gives me 390. Now I could also just go backwards instead of going positive. Probably should use a different color, but I could have went negative that amount. Okay, so instead of going counterclockwise 30, I could also go negative 330 counterclockwise. Or sorry, clockwise is what I meant to say. Okay, so that is the idea. Hopefully that's pretty easy. Let's keep going. Part B. This next one you guys try. It should be pretty simple. So what if I give you a negative angle to start with? Go ahead and try to plot that on the coordinate plane and also answer the question. Find a positive and negative coterminal angle. So pause the video. I'm going to go ahead and keep going here. So negative 150. First of all, we need to plot it. You don't have to, but I'll go ahead just to get more familiar with these. So the initial side's always on the positive x-axis. The vertex is always on the origin. And then I want to go negative 150. So instead of going counterclockwise, I need to go clockwise. Well, going 90 degrees would get me about right here to the y-axis. I need to go further than that, so it would end up being in the third quadrant. So that right there would be negative 150. Okay, so I need to get to that same position by going both directions around the quote-unquote circle. So in this case, I could take negative 150 and add 360, just like we did. So if I went negative 150 and then I went around the circle one time, I'd be back to the same place. And so I think that would be positive 210. And then let's keep going. Negative 150. To find a negative coterminal angle, I can subtract 360, go around the other direction. So negative 150 minus 360, is that negative 510? I'm hoping I'm right on that. I'm doing this in my head. I do have a calculator, but just want to make sure I'm right here. Negative 150 plus 360. Yep, 210. Negative 150 minus 360. Whoops. Negative 510. Okay, so that's the idea. Hopefully you find that pretty easy. All you got to do essentially to find coterminal angles is you add or subtract 360. That's it. And I could have kept going, guys. I could keep adding 360 to this. So if I add 360 to 210, that would get me back to the same position as well, which would be 570. Yeah, so 570 would also be a coterminal angle. So you could have answered 570 as well. All right, but we only needed one, so we need to find a positive and negative coterminal angle. All right, now this last one, I'm not going to draw, but I'll just go ahead and do the work here. So what if I said, instead of in degrees, what if we said in radians? Well, it's a good thing we've talked about radians in the past. So 2 pi over 3 rad radians. So since my since my question is in radians, I'm going to keep my answer in radians. I'm not going to convert it to degrees. I'm just going to try to write my answer in radians. We all know how many degrees are in a circle, 360. So that's how I knew what to add here and subtract. You add 360 and subtract 360. Now the question is, hopefully you guys remember, how many radians are in a circle? The answer is 2 pi. There are 2 pi radians. So if I'm at a 2 pi over 3 radians, if I'm at that position on my coordinate plane, and I'm just trying to think, I think that's actually 120 degrees, but I want to stick with the radians. Anyways, what was I trying to say here? I want to try to find coterminal angles to this. I want to try to find a positive coterminal angle and a negative coterminal angle. Well, if you look at what we did in the past, in degrees, all we did was we added and subtracted 360 to get a coterminal angle. So all you have to add here is just basically whatever it takes to make a complete circle. So in this case, it takes 2 pi radians to go around the loop another time. So with this idea here, we just take 2 pi over 3, and we add 2 pi, and we subtract 2 pi. Hopefully you can see that. Yeah, it looks like it. Okay, so all we've got to do is add these together. Now guys, this is just fractions. A lot of people get discouraged here. They look at this and they think it's too difficult. It's just adding fractions, guys. Before you can add fractions, you have to have the same denominator. So how can I make 2 pi have the denominator of 3? Couldn't I multiply it by 3 over 3? If you think about it, guys, isn't 2 pi the same thing as 6 pi over 3? Wouldn't 6 divided by 3 equal 2? That's where I get this 2 pi from. So I could rewrite this as 6 pi over 3. Let me write this down. So if you have 2 pi over 3 plus 6 pi over 3, isn't that going to give you 8 pi over 3? Yes, it is. And then from here, I could do the same thing. It's going to be 2 pi over 3. I'm struggling here. Minus 6 pi over 3. So what's 2 pi over 3 minus 6 pi over 3? Well, it'd be negative 4 pi over 3. And these are both in radians. So that would be your answer for your positive and negative coterminal angles. So that one's just a little bit different. You had to add fractions there. But still the same concept, guys. If you go 360 degrees around the coordinate plane, or if you go 2 pi radians around the coordinate plane, you're in the same position. All right, these are what's known as coterminal angles. All right, let me see how long this video has been. 17 minutes. Let's see. Let's do one more. Let's do one more problem, then we'll call it quits for this video. Here we go. I'll just leave that up there. I'll get rid of the other side. Whoops. I almost cracked myself in the head there. Nothing new. I think I've got brain damage from hitting my head on that TV that used to be in my room. I know Canon Stoneburner had a comment on that. All right, here we go. Last one. Here's our example. Let theta. And by the way, a lot of times, I don't know if I've mentioned this in the past, a lot of times we just let theta be, theta is the variable for an angle. Okay, so that's what we use theta. It's the Greek letter theta, T-H-E-T-A, theta. All right, so be the acute angle in standard position. So it's telling us to put it in standard position. Whose terminal side contains the point. I'll just say 5,3. I won't say the point. I just want to try to abbreviate here. And then it says find the 6 trig ratios. That's trig. Trigonometric ratios of theta. Okay. There we have it. Let's try to answer this. So this is kind of review from, well, section 4.2, and it's also applying what we've just learned in section 4.3. So let's get it going. So first of all, it says, let theta be the acute angle in standard position. When you hear that, what is standard position? It means I need to do what with my initial side? Put it on the positive x-axis, and then I need to put the vertex at the origin, right? Okay, so that right there is my standard position. Now, I also know my initial sides right here, my vertexes here. I need to know where my terminal side is. So if we're talking about it has to contain the 0.53, well, the 0.53 is going to be somewhere in the first quadrant. That means you go over 5 and let's just say up 3. So this right here would be my terminal side. It's going to contain that point. Okay. So what we can do from here, if we want to find the 6 trig ratios, what we've done in the past is we've had to have a right triangle. So whenever in this case, I need to draw a right triangle. Okay, so whenever you draw this right triangle, you always need to draw it from this point down to the x-axis. Okay, or depending on where the terminal side was. A lot of times, sometimes we draw it up to the x-axis. But you always drop this side to the x-axis, not to the y-axis, okay? So I need to try to make this a right triangle. That'll be a right angle. This will be my theta. Hopefully you guys can see that in the picture. It's kind of small. I'm sorry. I didn't draw the picture very big. So, guys, we know 2 sides of this right triangle already. Wouldn't this side right here be 5? The x value of whatever that point is. Let me go and write down the point. If point's 5, 3. Okay. And then wouldn't the y, the vertical side, wouldn't that be 3? Whatever the y value is of that point. So we know 2 of the 3 sides. So how do you find the third side? And I'll just call this, I'll call it R. I don't want to use X or Y. There's a reason why I'm calling it R, but I'm thinking ahead. But don't worry about this for right now. So how could I find R right there? I've got a right triangle. I've got 2 sides of my right triangle. How can you always find the third side? It's kind of a special theorem that we've talked about many times in geometry and advanced math, all that stuff. Algebra, you've seen it. Pythagorean theorem, exactly. So we would take 3 squared plus 5 squared is equal to r squared. So I can find r by doing this. 3 squared is 9. 5 squared is 25. And r squared is just r squared. And then 9 plus 25 is 34. Checking to make sure you guys can still see it. Yep. And so if I wanted to solve for r, what would I do? I would take the square root of both sides. So it's going to be the square root of 34. So now that I know that side, I'm going to go ahead and erase this and say this is the square root of 34. Now we can do our 6 trig ratios. Shouldn't be too hard from here now that we know all 3 sides of the triangle. So let me try to write them all out. I'm not sure I'll be able to fit them on this stuff right here, but let me try to do that. So actually, let me erase this stuff first, because I might need a little bit more room. I'll at least erase that. Okay, so we know r is the square root of 34. Okay, so sine. Let's start with sine. All right, so the sine of theta. Well, if you guys remember the trig ratio, sine SOHCAHTOA, sine is what over what? It's opposite over hypotenuse. So what is the opposite of this theta here? It's 3. What is the hypotenuse? Square root of 34. We just found it. Okay, let's keep going. Cosine of theta. Well, actually, I probably should pause right there and actually simplify this. So what would we do to simplify this, this fraction to get rid of the square root off the bottom? Hopefully you guys remember we would multiply by the square root of 34 over the square root of 34, which is 3 times the square root of 34 over 34. Okay, so that'd be your answer for sine. Cosine, let's do the same thing, except cosine deals with what? It's always what over what? So SOHCAHTOA, cosine is adjacent over hypotenuse. So what's the adjacent to theta? 5. The hypotenuse, still square root of 34. I'm going to save myself some work. This is the same thing as 5 times the square root of 34 over 34. Okay, and then tangent. Well, tangent is just opposite over adjacent. So isn't the opposite 3 and the adjacent 5? So it's just 3/5. Okay, let me try to write in the other 3. What's the reciprocal of sine? Remember, there's one co to go with each pair, with each reciprocal pair. So sine would be cosecant. Let me make Make sure I write the abbreviation correctly. Cosecant of theta. Now, with cosecant, all you got to do is flip sign, okay? So reciprocal of it. So I would actually start with what we had originally. This will make it a lot easier. So 3 divided by the square root of 34. If I flipped it, wouldn't that be the square root of 34 over 3? Hopefully that makes sense. Cosine, the reciprocal of that is just secant. So secant of theta, well, we would just flip this guy. So it's going to be the square root of 34 over 5. And then cotangent, that one's pretty easy to remember. It's a reciprocal of tangent. That's 5/3. Flip 3/5, 5/3. Okay, so hopefully this made sense. If it doesn't, don't worry. I'm going to be back soon. I'm going to be back Monday, so I know you guys are all excited, right? Right. So anyways, this is all I've got for this video. I'm going to stop it right there. Hopefully it wasn't too long, but I'll catch you guys later with this. I'll probably have an assignment for you guys tomorrow on this, just to kind of practice this stuff. So, and then I'll be back. All right, see you guys.